Hello, welcome to the channel. So we've got a Mesa Boogie on the bench, and this is a Lone Star Special, and this is in because it's got an arcing tube. You can see we've got, if we look in here, we've got a couple of channels by the look of it, which is gain, treble, mid, bass, presence and master. For those we've got a drive control here, and we've got some mini toggle switches on there, which looks like the channels select on there, drive and clean, and thick and thicker, which is about like me when I'm working on some of the amps. Sometimes I get thick and thicker. But anyway, pure class A power. Yes, I always get a little bit of a shudder when I see that. So to push tubes up into class A usually means excessive bias and plate voltage. So you can see in there we've got a couple of tubes missing. I don't know if they're in the bottom, are they? I really could have done with those. And of course the other thing you always think about with boogies is the conductive boards. I haven't worked on a lot of boogies, to be honest. I never don't see that many. I think we'd better get the current limiter on it before we start. We'll start with a 100-watt bulb in there. We'll switch on and see what happens. Oh, we've got a fan in there. We don't appear to have anything, so I wonder if the fuse is blown. We've only seem to have one fuse. Rectifier tube is lukewarm. Let's put another bulb in. Just put another 60 watts in with the 100. Fan's giving us a bit more swage now. We've got 190 volts going into it. Well, the conducting, or the rectifier tube's conducting anyway. Let's see if anything else is conducting. Such a big old thing. I can hear the reverb. So I think we've got something there. Yes, we have. Very quiet. Right, so we know it's running. Right, let's shut it down. See if we can find a couple of tubes to go in it. Right, so we've got a pair of tubes in there. Customer says it was just arcing on one tube. Well, let's just start on a 100-watt bulb here, because we need to keep this amp pinned down, because if there's a fault on it, we don't want to do any more damage. Now that one feels warm, that one doesn't. So I wonder if it's blown the screen resistor. May have blown the screen resistor. I've got 183 volts going into it, and it's drawing 300 milliamps. 54 watts. So let's get the signal generator through it. Yeah, those are hot, although they have been on longer, to be fair. But that one feels pretty cold. Just going to turn this light out for a minute. Make sure I can see filaments in them. Don't actually know whether that eddy current tube's got... It's getting a bit warm. Yes, I can see filaments in that. There's not a lot coming out of that, is there? That should be blowing the roof off. Scratchy pot. Right, so we've got it out on the bench, and the first thing I see on this is this bolt here. We just lift it up. Is this bolt? So we look on, if we turn it upside down, we've got this random bolt sticking through here, which is higher than the actual chassis. So now I've just took the 4 bolts out the top. I've just checked there's no hole in the cabinet for this, so I have no idea what that's doing there. That's bizarre. So the first thing is to get rid of that. No idea what that's about, because it's as I say, there's no fixing in the cabinet for it, so that one bemuses me. So something else I've spotted as well in there is this resistor here that kind of looks like it's been added, and the soldering's not that sparkling, so I don't know whether that's been added at some time. Don't see anything burnt up. The output tubes sockets are underneath this speaker, the board with the speaker sockets on and whatever, which is just marvellous. This board is so thin on here, and you can see it's warped. You perhaps can't see on the camera, but it's warped pretty badly. I suppose we best get into it and get the meter on it then. So we've got those couple of tubes in there, we'll leave those in. We'll keep it on the current limiter for the time being. We need to get a speaker on it now, don't we? There's a switch on the back to turn that fan off, so I've turned that off. That sounds like DC to me on there. No, there doesn't appear to be any voltage on there, so it probably is just a really dirty pot then. I can't get into there. go on to the other channel. There we got channel 2. Master. That one's the same. Dear oh dear. So everything seems to be running again. Still on the current limiter, though, so we're not out of the woods yet. So I've got that middle tube, they're lukewarm. I don't know. Right, let's go up another 40 watts on the bulbs, so we'll have 200 in there. Wow, that's warm. We're drawing 330 milliamps. I have to do a bit of testing now and just see what voltages we've got. Now we're on the 30 watt setting on here. I've just spotted that on there. And now we've got, let's just see, test that, 'cause it's got 380 milliamps. Let's just bring that down. Yeah. Oh yeah, I can see the bulb's getting brighter. So that's switching those middle two tubes in then. So that's 5 watts, got 330 milliamps. 15 watts, still got 330 milliamps. But then when we push it up, we've got 390 milliamps onto the 30 watt. The last Mesa Boogie that I did was the preamp. I did a video on that. I'll leave a link to that one. Right, so I've got a meter up there. I'm going to have to change the battery on the camera soon because it's only got 6% left. Making sure the meter works there. I can't really get into these sockets very well, but that's the screen, 251. That's the plate, 250. Yeah, pin 7, 6, pin 5, pin 4, pin 3, yeah. So let's try this one, pin 9. That's the screen. Let's try this one on the end. Pin 9. 246. Remember, we've got the current limiter on, so these will. So we've got voltages on the screen, so the screen resistors aren't popped. So it looks like it's just a tube. Then it's, oh yeah, they're conducting nicely now. Yes, they're swaging. So let's take off the current limiter. 570 milliamps, 580 milliamps. Right, let's see, we need to turn down the volume now to test these. 337 on the screens and 340. So no, not an excessive amount of plate voltage there really. I would have, reading what I saw on the front, I was thinking that they might be pushing the bias up on the tubes to keep it in class A, but got more volts on the screens they've got on the plates. 339 on the screen and 334 on the plate. So if we just zoom down, this is the cathode resistor, I think, because if we go down into there, we've got 9.7 volts. If we go on to pin 3 here, we've got 9.7 volts. So that is the cathode resistor. So the amp's running fine. We've put a couple of test tubes in it. It seems to be running fine. Just a bit concerned that I've got 1.3 volts on that grid. And I've got 1.3 on that grid. I've got 0.7 on that grid. What have I got on that grid? 0.7 on that grid. So I need to find, I need a schematic for this really. But what I'm doing now, and you can't see, is I'm going between the pins on the board to see if there's any leakage anywhere. If anything is leaking across on this board, although it could be inside the board. And that seems to have cleared now. That, or was that just when it's on the 15 watt? It's when it's on the 15 watt. How weird. Wow, that is weird. And then it clears itself. Put it back on the 15. That's the volume pot that we was turning earlier. Let's try it on the 5. Just the same. See how it fades out on the 5 and then it's gone. What a bizarre, that's bizarre. I've never seen that, and at this moment in time I couldn't even tell you what's causing that. But there's no DC on it, none whatsoever, so I don't know what's causing that. So that's the 5 watt. That's on the 30 watt. Let's just cruise down and have a look at these controls. So on this channel 1, so you can flick it into that mode there. Imagine that, then only the switch will work it. It says SW, I presume that means switch. So we've got clean and drive. Let's flick it on drive. Well, that might be for channel 2, I don't know then. That's the drive channel. Let's turn the master down, blast up the gain. Well, that's about 40. Let's take the bass off. So the drive only works on channel 2. Let's just take some treble out there. That's let's crank this. Also starting to smell rather warm. It is. Just turning this output control here Sorry, there's a master volume. Oh no, I've got master volumes there, so maybe that's for overall for both channels. Oh no, that's the loop. To be fair, we have not got this on a very good speaker, so got some nice gain there. Flick off. Yeah, that's nice. Well, it seems to work okay. Let's check the bias on those tubes and make sure they're not running too hot. Right, so had a bit of a look into some of this biasing on this amp and was getting nowhere with it. So I went online to look for a schematic and found one on the EL34 website, and this schematic has given me a few clues as to what's going on with this resistor here. So that resistor is a mod that someone's done to reduce the dissipation on the 15 watt setting. Reading through this schematic, and it's took me a while just to sift through it and how this is working. So the 30 watt setting uses solid state rectifiers and the 5Y3 from what I can see, but when you're on the 15 watt setting it only uses the 5Y3. So that's just a rough explanation of what's going on. When it's flicked onto that 5Y3, it's only running these outer two tubes, the outer two, and that resistor's been put on to reduce the bias. Now this is where it gets even more strange with this amp. This 110 ohm cathode resistor, this 10 watt cathode resistor that you can see here hiding, partially hiding, that is for the inner two tubes only. And these two here, these 200 ohms are wired in parallel for 50 ohms, and they are the bias resistors for these outer two tubes. But when it's switched onto the 30 watt, it then adds another resistor which is here, which is a 68 ohms in series with those, which gives us a total of 118 ohms. So in the 30 watt setting, the inner two tubes have got a 110 volt cathode resistor, and the outer two have got a 118 volt cathode resistor, or should we say 118 volts of resistance made up of 3 cathode resistors. And then it gets even more weird. So if you look here, and one of the things that Mesa Boogie have done with this amp is nearly all the component identifications are right underneath the component. The fact that these two are showing here, if we just go in a shade more, is because they're missing and they've been removed. And it says R103 and R101 470 at 1 watts, 470 ohms. So that 470 has been in parallel with this 100, and this 470 has been in parallel with this 100, and these two hundreds, as I said, are in parallel together. So that gave a combined total of 45 ohms, which then made this amp run even hotter. So someone's removed those, which makes sense. And then we've got this mod here, which I'm not sure if that does make sense. Soldering's not great on it, as we pointed out earlier. So we need to do some tests and find out exactly what's going on with the bias in this amp, because I've got to put 4 new tubes in this amp, and I'm not putting them in until I know that, you know, something in here is not going to blow them, and even if it doesn't blow them straight away in 2 weeks time. So I need to make sure that this is all correct. This bias system that they've got going, it works on these switches, on these 30, 15 and 5 watt settings. So here we've got the schematic of the output stage of this amp. So we're going to have a bit of a look at this. So I've marked this in 3 colours. So the green here, this is the inner tubes, the inner 2 tubes. The red is the outer 2 tubes on the 15 watt setting, and the blue is the 5 watt setting there. So let's look at this switching on here, which was a bit confusing when I first looked at this, but then as the more I studied it, the more it made sense. So let's look at what happens when this amp is in 30 watt setting then. So we've got 110 ohm 10 watt resistor, and when it's in 30 watt, that is connected straight to ground there. The 15 watt coming from these 2 cathodes here, these are the outer tubes. You can see that they come down to these 4 resistors, the 100, 100 and 470 and 470. Remember, those 470s have been removed, so we've just got the hundreds in parallel. And then it comes down here, but when it's switched to when it's in 30 watt, which is what we've got this in now, it comes down here and goes through this 68 to ground. So when this is switched in 30 watt, this is disconnected here to ground. Let's just say that again. So when this is in 30 watt mode, the inner tubes are connected to ground, but the outer tubes are not connected to ground here, and so so the signal that comes along, or the voltage, whatever you want to call it, it comes along here, it goes down there and goes through the 68 to ground. That gives you a total, these 2 are wired in series, remember, so that's 50 ohms plus another 68 gives you 118 ohms. That's where we're getting that figure from. Now when this amp is switched into 15 watt mode, this disconnects this cathode altogether, and these tubes become redundant, these inner 2 tubes. So now the outer tubes are just running on their own, but whilst that gets disconnected there, this now gets connected up to there, and that straight to ground there becomes the path of least resistance. So it goes along here, goes straight to ground, cancels out that resistor, and now we've got 50 ohms for the bias instead of 118. So the 5 watt works simply by removing that parallel connection, and as it removes that, as you switch to 5 watt, it disconnects that, and then the cathode resistor for the 5 watt setting becomes 100 ohms on these 2 tubes, on these 2 outer tubes. So the 5 watt uses the outer tubes, the 15 watt uses the outer tubes, and then obviously the 30 watt uses all 4. So that's how that's working. Very bizarre circuit. One could say almost ingenious. So now let's have a look at the power supply. So here's the power supply. So we've got diodes, and we've got a 5Y3 there, and we've got a switch here. All these switches, by the way, you can see on here, they're actually relays, and the relay for this is actually under the board with the tube sockets on. It's at the side of the rectifier tube socket. So when that relay switches is closed, that will be the 30 watt setting, and we're getting the voltage from these diodes. And here, if we look here, we're getting the voltage from the 5Y3 also going up there. But when we switch to 15, this relay then disconnects, and then you only get the voltage from the 5Y3. And you can see here that this and this diode connect there, so that's broken there. And so this then this feed from the 5Y3 comes down here, up here, and goes on to the power supply there. And here we've got the supposed voltages that whoever's done this schematic has measured all these. So 357 on the 30 watt setting, 274 on the 15 watt setting, and then we've got the choke, and then we've got the feed to the screens, 254 and 270. In actual fact, we've got more voltage on the screens than we have on the plates, so not sure what's going on there. And then we've got a 5.6k dropper, then we've got 312 or 238, depending whether you're on the 30 or 15 setting. He's also done some tests here and put the current on here. So at 30 watt we're drawing 230 milliamps, 15 watts 152, and 5 watts 152. So that's basically what's going on there with the power supply, and that's how this amp works. Now, to test all those theories and how I've actually done a few bits and bobs testing and things just to see where we are with this, and part of that I've done is this mod. I'm never comfortable with starving plate voltage by using resistors, or B plus or HT voltage as we call it in this country. I'm never happy with that, and technically to do that to bias an amplifier is wrong. You would alter the cathode resistors, but in this instance I'm a bit on the fence with it, because this amp is a difficult thing to balance with all the setting, the 30 watt, the 15 setting, and so on. So what we're going to do, we're going to do some tests. We're going to jumper this out as well and do some tests and see what the bias was. Now I don't have the original 2 tubes, so we're using a couple of tubes that we've put in here, a couple of test tubes, but we've still got the outer tubes are still original. So we're going to do some tests and take some readings and find out exactly what's going on with this, what voltages we've got, what biases we've got, before we stick the new tubes in. If we go back to the power supply schematic again, just turn that light so it give it more contrast. You can see we've got 100 ohm resistors on these screens, and that's something else that I'm not keen on either. That to me is nowhere near enough. And remember, we've got more in actual fact, he has tested on here, he's got his test voltages and he has got more volts there. He's tested 354. I actually tested even more than that. I think it was about 7 volts. And the thing is, pushing these EL84s, overvolting the plates, it's generally okay. People have done it for years. Vox did it, or overbiased them at least. Most people Black Star do it on the Artisans, Marshall do it on some of their amps. We looked at a Marshall amp, and I can't remember, was it a DSL 20, and that got 395 volts on the plates of an EL84, and that got JJs in, and they were running that fine. The paint on it looked a bit baked, but they were running. But the screens you know, chances are that tube's arced out. Maybe this, you know, maybe the screen's shorted to cathode or whatever, I don't know. But I would like to get the voltage down on the screen a bit and get a decent sized resistor on the screens for the current there to regulate the current better. Now those screen resistors are on the other side of this board, and that brings me to another problem I had with this amp. So I came to switch this amp on later in the evening and it didn't work. It was the power was running through it and we'd got current on the current meter and all, but there was no sound. So if we look here, we've got the speaker sockets. So I was plugged into this socket. I pulled it out, put it in this one, it worked. I pulled it out, put it back in there, it worked. So I don't know whether there's a problem on this board somewhere, and obviously there's quite a bit of heat probably rising up here from these tubes, so it's obviously getting into these to this board a bit. So I really want to take this board out and have a look underneath, and I actually really want to take this board out and have a look underneath with the tubes, because if we've had an arcing tube we may have a well burnt screen resistor under there. Now we've tested these screen resistors and they're still okay. They test at 100 ohms, but that doesn't mean to say one of them might be badly burnt when we get under there, and if it is, then we need to change that. So I think I'm going to have this board up and just have a look underneath it, just for peace of mind. So let's have a look at this mod in a bit more detail then. We just go in and have a look, and if we go in, you can see that there, and where else, two places, there and there, the trace has been cut, and not very well either. If I was cutting a trace, I would want a bit more gap than that, and they've barely cut through that one there, but it has been cut, and they've done that for this mod. Wire's been brought round from the relay, and the relay is under the board. You can see that when you go there, the switching relay. That switches when you switch from 15 to 30 or 30 to 15. That's the switch that changes the power here. So they've cut that trace, they've added that resistor, and then they've cut that trace. They've added this wire in there, and that is dropping, I can't remember now, we'll have to look again, but it's dropping a few volts off the plates of the tubes, off the HT. We're going to bridge that out and test what it would have been originally. Now I had a chat with the customer about some of the problems on this amp, and he would like this putting back to original, but of course that will depend on all the test results. Now obviously the guy that drew the schematic is very accomplished if he's drawn that schematic, and in a sense that he's actually worked out this circuit. You know, it's a very difficult circuit to work out, and the guy's worked it all out. So, you know, he's a clever guy that's done that. I don't know whether the guy that drew this schematic is the same guy who's done this mod. And my suspicions is it's not that guy that's done that mod. I don't know. I've just got a feeling it's not the same guy, because that soldering to me doesn't say mega accomplished tech. So that's just a hunch, and that was downloaded off the EL34 website, and I really didn't read the forum or anything. I was so keen to get the schematic, I just downloaded it. Right, so the first thing, I think the best way to approach this is to measure out the cathode resistors first. Now to do that, you've got to use the switching on this amp, and obviously if we're testing for resistance, we don't want voltage on there. So the best way of doing this is to put the amp in standby. That way the relays still work, and you can actually, you probably can't, but I can hear them clicking. So I've got one side of the meters to ground, and if I go to here, oops, hang on a minute, hang fire, let's get the meter set properly. So I'm measuring here on the cathode resistor there to ground. So if we look up there, you can see we've got 111 ohms. So that cathode resistor there is for the inner two tubes. So, and you probably won't be able to see this, but if I get under there onto the cathode pin, which is pin 3, and then if we go up here, you can see, let me just try and get the light off this, you can probably see that's 111 ohms there. So that tells us that that cathode resistor is for these two inner tubes. So now we're testing to ground. Right, so let's test the outer tube and see what we've got on the cathodes there. On the outer tube in the 30 watt setting. And if we lift that up, the camera up there, you should be able to see a bit of a distance away from it. We've got 128 ohms there. So that's over, because on our calculations we've got 50 ohms and then we've got another 68. So that tells us that's over. So how would we test those resistors individually then? Going back to our drawing again here, I have to be careful now. I'm just going to switch off, because I don't want to be putting my fingers underneath to pick this paper up and getting a nip. So let's look at our 68R here, 68 ohms. Testing that resistor with the amp switched off is no comprende. You can't do it. It will just test as if it's 0 ohms, because when you switch the amp off, it's closing this up, and so that then is just, it's as if it's jumpered. So you've got to test this 68 ohm resistor, you've got to put the amp in standby, and you've got to switch it to the 15 watt setting. Oh sorry, it'll be in the 30 watt setting. To test these two, these hundreds are wired in series at 50 ohms each, so I'm guessing if we switch it to 5 watts we'll be able to test those as well. So let's put that theory into practice. Power on, leave the standby off, and be careful what you're doing with this. Remember, the amp is switched on, although it's in standby, there's still some high voltage in here. So if we go back to the 30 watt setting and go in, we can see that that resistor is 75.5 ohms. I'm now going to go to one of the 50 ohm resistors, and if I measure that, I'm getting 49, and if I measure the other one, we're getting 49. Now let's flick to the 5 watt setting. Oh, now getting 11 ohms on that one. What are we getting on this one? 100 on that one, yeah. So we can test that one, but we can't test the other one. Not quite sure why that's we can't measure that one, but anyway, so that one's extremely accurate. But the main problem is that 68R. That 68R is out by quite a bit, and it does look a bit baked actually. That does, a bit baked. Let's start writing a few things down then that we've discovered so far. So the 30 watt setting, the cathode measurement and resistance was 111 ohms. And in the 15 watt setting, the cathode measurement was 128 ohms. So let's look at the 5 watt. So if you wanted to measure the other 100R, you would have to take it out of circuit, but you can measure the one on the right there. So we're on 5 watts. Let's go to the cathodes. Oh yeah, it's going to be the outer tube. We've got 103, so a little over on there. 100, if we just look up there, you can see we've got, you probably can't, you can see we've got 103. So we'll write that down. So now we need to go for voltage drop over the tubes, over the cathodes. So now we can power up. So we put the standby on. We're on the 30 watt setting. And we'll go to the cathodes again. So we'll go to the outer cathode, the outer tubes. We'll put the meter on volts first, so it makes sense. And we've got 11.5 on the outer tube. So you can't really see much on there, so let's view the meter instead. Outer tube 11.5, and that's with that'll be 128 ohms of cathode resistance. Let's go on to the other one, outer tube, check that, 11.5. Now let's go to the inners, 8.7, so 8.7. So let's go on to the 15 watt setting, and we've got 5.1. So 5.1 on the 15 watt setting. Remember, we only got 2 tubes there, so we'll only have one set of figures. Now let's go to the 5 watt setting, and again we're only on the inner tubes, sorry, the outer tubes. So on the 5 watt setting we've got 5.2. Let's just check the other tube, the other side. 5.2. So that brings us round to the voltage, doesn't it? The plate voltage. Now that's got to be plate to cathode, remember, because this amp is cathode biased. So let's go back to the 30 watt setting. And remember, we've got 2 different cathode resistors, so of different values. So we're going to have to measure. We're not just measuring from one cathode. We've got to measure the cathode to plate on the outer tubes, cathode to plate on the inner tubes. So let's start with cathode to plate on the outer tube, and we've got 320. That's all over the place. That's dropped. 323 then, we'll call that. So now we've just got to measure one of the inner tubes from its cathodes. Sorry about that. Has that got that? Again, that light is a nightmare. So let's just turn that away. Try that a bit better. So the inner tubes, 329 we've got on that one, which is to be expected, a slightly different voltage. Now let's look on the 15 watt setting, what voltage we've got. So that's on the outer tube, so let's see what we've got at the 15 watt setting. So plate to cathode again, 224 we've got on there, but remember that is with our 130 ohm mod that we've discovered on there. So let's check the 5 watt setting, 228. So there we go. So we've got all our figures for the bias. So we'll we'll switch off and we'll do a bit of maths. Right, here's our results then. And yes, I've got the plug out because of the metal on there. Having that over the amp. So 30 watt setting, outer tubes. We've got 14 watts dissipation. The tube including the screen current is 45.7. 14 watts. So that's 2 watts over for the outer tubes. Inner tubes 12.03. So there's a bit of a discrepancy going on there. Now if we come to the 15 watt setting, 10.25 watts, but remember that's been, the plate voltage has been reduced by the 130R mod, which we're going to get onto in a minute. And 5 watt setting, we've got 5.46 watts. We've got 25.2 milliamps total current on the tube. On the 15 watt setting we've got 47.5. So that tells us that we've got the outer tubes at 14 watts, should really be 12. The inner tubes are set absolutely fine, they're on the 110 ohm resistor, and that's the thing that's a bit bizarre about this, which it's looking like it's down to the tubes. The 128, the 30 watt outer tubes have got 128 ohm resistance, total resistance, 128 ohms total resistance. So we've got more resistance on there, but we've still got much more current being drawn. So is that to do with the tubes? Well, we'll swap them over and see what happens with that. The 15 watt setting's fine, but what we need to do is jumper out that 130 ohm resistor and see what that figure then is. Obviously it's going to be higher, but the question is how much higher. And the 5 watt, well, that will be higher with the 130 jumpered also, but at 5 watts we're not really concerned about that because that's already way under there, so it won't make that much difference to that. I've jumpered out the 130R, so just put a clip lead across it. I'm just going to switch the current limiter on when I fire up because I've put that clip lead on just to make sure that I pull the plug out, haven't I, because of the pad. Right, so we're on, no problems. So I'm just going to flick the current limiter off. Always put that on when I'm clipping something on, because you just never know, especially with PC boards, loads of terminals around. So now I need to be on the 15 watt setting, because that mod is only for the 15 watt setting. So it's on the outer tube. Let's see what we've got now. We've got, and if we go up, I can tell you we've got 5.73 volts, 5.73 volts drop on there, but now our resistance will only be 53 ohms on there as well. So we need to remember that. So now we need to get the plate to cathode the plate to cathode voltage. And that is now 250 volts. So what was that before? So let's do the maths on that. 12.62 watts. So that wasn't worth the mileage, was it, that mod? But then I suppose it depends what tubes are in this amp when it was done. So if it's tubes that draw, you know, high current, then may well have ended up with, and I guess that in this amp there would have been, on the one that the guy's done the measurements on, the customer wants that going back to original, and I think I'm inclined to agree with him there. I think if we put a set of JJs in this amp, we wouldn't have any problems with it being over dissipated. That's what I personally think. But now, where do we go from there then? So we've got that discrepancy now between the inner tubes and the outer tubes on the 30 watt setting, and as I pointed out, despite having more resistance on the more resistance on the outer tubes, we've still got more dissipation. So what we need to do now is swap the tubes over. Right, we've swapped the tubes round. We're just letting it warm up a little, and then we'll do some more testing. So let's recap from our previous settings. We've swapped the tubes around, so let's look at what readings we had before we swapped the tubes around. So we're on the 30 watt setting. On the outers, before we swapped the tubes, we had 11.7. Let's check what we've got on the outers now. We've got 9.1. So let's look what we've got on the inners. We've got 11.3. So we've virtually got, on the outers we had 11.7 before. So we've virtually got the same voltages. There's no point doing the bias readings. We already know now from swapping the tubes that all we've done is just swap the figures around on the dissipation. So we know those tubes are badly matched. To be fair, I've just picked a couple of tubes out of my stash for which are just test tubes. So, but the more important thing now will be on the 15 watt setting. So we're going to go on to the 15 watt setting. Now we're just dealing with the outer tubes. So on the 15 watt setting before, we had 5.1. Let's have a look what we've got now. 4.2. 4.2 and divide by 53, which was the cathode resistor on the 15 watt setting. That's giving us 79 milliamps per tube. Sorry, 79 milliamps for both tubes. We need to divide that by 2, take away 5% for the screens. So we now have got 37.6 milliamps per tube. But remember, we've got the mod going on still in the 130 ohm resistor going on the power there on the 5Y3. Let's check the plate voltage, plate cathode. 247.8, 9.37 with the mod. So obviously putting the cooler tubes in, that's gone down even further. Last time we had 10 point something. Let's just see what we had last time. On the 15 watt setting we had 10.25. So no doubt about it, cooler tubes in this amp work really well. So JJs generally run cooler than, say, Electro Harmonics or Softex. So in my experience anyway. Tell me what you think in the comments. What do I know? So we're on again, but we've got our 130R resistor, our mod resistor that we've discovered, as I said. We've now bridged that out again, jumping it out. So now what we need to do again is do the measurements again. So we go to the cathode. So that's with the mod bridged out. 4.3, we'll call it, yeah, 4.4. I think that tube's still baking a bit, although it's not been off long. It's gradually still getting up to full swage. 4.5. We'll just give that tube a minute just to swage itself. So we'll call that 4.66. So we'll check that. 4.66 divided by 53, which which is the impedance, the resistance, and that gives us 87 milliamps a tube. Divide by 2, take away 5%. Now we need to get the plate to cathode voltage. We expect that that's going to be higher. Well, we know it's going to be higher, don't we? So we just need to check that. So on there, pin 3, 267.6 now, so quite a bit more. 11.17. So let's look what we had before we swapped the tubes with no 130R with it jumpered. 12.62 watts, 53 milliamps. Yeah, 12.62. We've now got 11.17. So I'm pretty confident that that mod can go. So what will happen if I put a matched quad of tubes in this amp? The tubes will be matched, but the dissipation probably won't be matched, because the inner tubes have 111 ohm of resistance on the cathode, and the outer tubes have 128 ohms of resistance, so there's going to be a bit of a discrepancy there. If we put the new tubes in and we find that the dissipation is over on the 15 watt setting without this resistor in there, I think we should alter the cathode resistors rather than having this in there. Now we'd have 3 cathode resistors to alter to try and match up this bias, and the trick would be is to try and get a reasonable match on the outer tubes in the 30 watt setting, but also get 12 watts dissipation on the 15 watt setting. So for instance, we could up these two to 120, which would give us 60 on the 15 watt setting, but on the 30 watt setting with the 75 on there, that would give us 135, which would then be considerably more out than this here. So if we increasing these two resistors to say 60 ohm, we need to decrease this resistance on the 68 ohms, which is for the 30 watt setting, and try and balance this up. You can see what I'm getting at with this if you're following. But we'll worry about that when we eventually get the tubes in. So this is what I've come up with this amp. Customer wants this mod removing, and I think that's probably a good idea. And it just doesn't look very tidy either, the way it's been done. And if you're out there watching this and you've done that mod, I'm sorry, but that is my opinion on it. So what I propose for this repair now is I'm going to take this board out, because I want to make sure there's no problems on this board. Remember, I switched it on that one time and I was getting nothing from it, so I want to check that. And I want to take this board out, and it's very flimsy, this board, and it's the one thing I don't like how they've done on this Boogie. What they've done here is the tube socket for the 5Y3 is taller than the standoffs on here. So instead of increasing the standoff slightly, all they've done is just bent the board up like that. And to me, that just, I mean, this is a really expensive amp. To open it up and see that sort of workmanship, I'm sorry, that is shocking to do that. Least they could have done was to get these standoffs up level with this tube socket and not bow the board like that. Tell me what you think in the comments. But that's what I think. So I'm going to take this board out and I'm going to check underneath to see if any of these screen resistors are burnt up. But as well as that, I'm going to swap these screen resistors because we have got more volts on the screens than we have on the plates. So I'm going to put some 1K resistors in this. 1K screen resistors. That's what I propose we do in this. And that will regulate the current better on the screens, and the tubes will last longer. Simply they will. They'll just last longer. And try and avoid this, you know, problem where tubes end up flashing over inside because they're just being hammered, and the screens are being hammered more than anything. You know, if you're going to overvolt a tube, then overvolt the plates, but overvolting the screens, you are always going to shorten the life of the tubes. So that's what we're going to do for this repair. We're going to take this out, check it all over for any dry joints, clean the sockets and everything. We're going to take this bottom board out. We're going to replace those screen resistors 100 ohms to 1K. And I know what they're trying to do with this 100 ohm screen resistor deal here. It's like on the Vox AC30s. It's this Class A obsession again. And I'm not getting into the Class A debate, and please don't drag me into it in the comments, but there's always been this bit of a myth that the Vox AC30s are a pure Class A amp. They aren't, and any tech, you know, will tell you that. And it's the same thing with this. They're trying to keep this amp in Class A as far as they can get it up the dial. All it does is creates a very hot amplifier and a very short life for the tubes. We're going to remove the mod, put the 1K screen resistors in, check this board, put a quad of JJs in it, and I think that will get this amp bang on. And if there's some discrepancies with the matching the bias, then we'll try and match it in with these resistors and this resistor here till we get it right. So this will be part 1, and in part 2 we're going to come back and I'm going to do the work, and we're going to run this amp up again and see how we get on with it. I'm going to get in touch with the customer now and just let him know what we've done and everything. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in another video. Bye bye for now.